This one's from the book. It's a work problem. That must be number 6. It's pretty challenging. There's different ways to think about it, actually. But what it is that this cement block is being moved up 30 feet, and the rope is also being moved up. So the idea is, how much work does it take to move that weight up 30 feet using that rope? So first we realize, and this is just one way to do it, that there's 45 feet of cement, 45 feet of rope plus the cement is going to move up 30 feet. So we have 75 feet total. 75 feet. So this whole bit of 45 feet here, plus the weight, can move upward 30 feet until it gets to the location it needs to be, 30 feet off the ground. The rest of the rope up at the top, that's varying as to how far the bits of that rope have to travel to get to the top. So first we're going to do the 45 feet of rope plus the cement. 45 feet of rope and the cement is lifted up 30 feet. So work sub 1, I'm just calling it that part of the work, is the rope weighs 0.5 pounds per foot, and it's a 45 foot piece of rope. So that's how much that weighs, 0.5 times 45, plus the 500-pound cement. So that's the force, that's the weight that's moving up 30 feet. We should put a, to be consistent, we should put a feet there. Okay, so you do that math and you come up with 15,675 foot-pounds. That's that work. Now we work on the remaining top 30 feet of rope. Now, some of it has to be moved pretty far, but some at the top doesn't hardly have to move any at all. So that's where the calculus part comes in. So we take a delta y piece of rope at a y location, and I'm just keying on that these y's start here from 0 to 30, and that delta y foot piece of rope weighs 0.5 pounds per foot times how much feet you have. You have delta y feet. So this is how much that weighs, 0.5 delta y. At a y location, right here, at a y location, that piece must be lifted 30 minus y feet. 30 minus y feet. So the work for the top piece of rope to lift it is the weight times the distance, force times distance. Sum those all up as your y values go from 0 to 30. So the work for the top piece is going to be the integral from 0 to 30 of 0.5 30 minus y dy. And that comes out to, when you run that integral, it's 225 foot-pounds. So you add that to the previous work of just the bottom part of the rope and the weight, and you get the final answer. Adding those two together, 15,900 foot-pounds.